I think I also like to welcome, it's a great opportunity to speak for your colleagues. It's not many of these opportunities, so I'm really happy about it. And I think we also have a group from the IBDI in Brazil, is that correct? Yes? Então, boas-vindas especiais para o grupo brasileiro. Então, well, it was not until I was preparing my presentation that I realized that there was a misunderstanding. I'm not going to talk about an option. I'm going to talk about a must. Because an option is something related to choice, freedom of choice. Yeah? And you can have an option of having nuclear power or not, but you cannot have an option to use systems approach or not, because you have to use it to deal with the complex questions that we are facing. We have a global primary energy supply that is heavily dependent on fossil fuels, hydrocarbons, and it has doubled in only 27 years. The challenges are both related to socio-economic development, where we, for example, have to provide electricity to 1.5 billion people in the world who literally are outside the market because they have $1 or $2 per day, and therefore they are automatically, by definition, outside the market. And we are operating in a market economy. Most of the tools, most of the mechanisms we are creating are market-oriented. We have to address climate change, and we have to reverse trends towards more use of energy, and all these different things have to be done in a context of the minimal disruption possible, both in the natural environment but also in the socio-economic systems that we have in that bear our society. So how do we conciliate this very broad and complex goals? So a systems approach is a must. We cannot deal with the complexity of these questions by simply making intuitive choices. We need to understand the evolution of the energy systems and how they interact with other productive systems in the society. For example, in Sweden, we have a very strong relationship between the forestry and pulp and paper industry and the bioenergy segment of our energy system. We need to verify the sustainability of the options that we have at hand and how they will play a role within the total context, what services actually are going to be provided. And we need to plan the transformation of the energy systems, the future energy systems that we are going to live with in the next 20, 30 years. We are deciding upon them today. So we need decision support systems that actually help us make the best choices. And again, within this complexity, we cannot simply use intuitive methods. At KTH, I'm not going to speak only about my research. My research group has 5 posters in the back of the room. I'm going to give a few examples because we are different groups working with this type of approach at KTH, and we are actually trying to form a basis for a systems analysis centrum. So this is the last scenario prepared by the International Energy Agency, and it shows you, this spectrum of colors shows you also the different actually options that are being suggested in this scenario, and there are other options. If you just look at studies made a few years ago, some of the options were not there. Like, for example, the CCS, which is carbon capture and storage, which now is being contemplated as an important alternative when it comes to climate change adaptation. This is now I'm going to give a couple of examples in short, because this is related to the work of other colleagues at KTH, and it's a little bit unfair to try and describe in depth the study of others. And then I will talk a little bit more about one example related to bioenergy. So if we want to ask if we're asking the question, how can we build a future sustainable energy system in Sweden? And you have a target of, let's say, somewhat around 11 million tons of CO2 emissions by that by 2050. So you can actually contemplate what are the technological alternatives you have, how do you expand and explore these alternatives in different contexts, what is in the pipeline that can come and make a contribution. And yet in this study we can see that technology is not enough. So just technology is actually important, but it's not enough. So more will have to be done. And then you need to evaluate which scenario. Sorry, this slide came out in Swedish. But basically the idea is that you need to verify if you're going to have a target of an energy per capita of the order of, don't have a pointer here, but the energy per capita, or half of the energy per capita that we use today by 2050, then you have a certain number of options, and how can you play with those options? And those options may vary depending on the context in which you are and in the types of energy demand you have. For example, in a cold country like Sweden, we need a lot of heat. And that's an important energy service that we need here, and it takes a lot of energy that we use in the buildings. Another example is related to the work of another group at KTH in the ABE school, related to the issues of urbanization. Urbanization is moving very fast in the world, and within the urban context you have a number of different functions operating, and these functions they have an interplay, and they have a very strong impact in the environment, both within the urban environment but also outside the urban environment, where then we need to bring the energy that is needed in this urban environment. In that context, also energy systems analysis tools are being used, for example, for strategic environmental assessment, a requirement today for major programs. For example, this afternoon we have Pernilla Barroto, who is going to speak about the new launched program in the EU, which has very many huge programs. And here you need a strategic environmental assessment to see what the impact is, not only on the environment, but actually in the socio-economic development of the region that is directly affected. Environmental impact assessment, which most of you must have heard about, is then related to the project itself and what impact it can have. And this type of methodology is actually becoming very very important, even in broader contexts where we discuss, for example, impacts of land use change in different places related to energy use in other parts of the globe. So quite complex type of questions. My own group, we like to define, to look at the energy system and the challenges within the energy system as being technological challenges which have the questions of themselves, like how you develop the technologies that you want to put in place, the structuring of markets where we have many actually actors in the market today, and the old type of regulation that we have is being changed into a re-regulation of the system, because the more actors you have, the more you want to know the rules. Just imagine if you have a football game with 24 players playing according to different rules. It would not be as much fun. So it would be certainly not be very successful.